Today we've only got two things we need to look at. I can determine if a relation is a function, and I can use other names other than x and y in describing parts of the ordered pairs and functions. At this point you have no idea what's going on. We need to learn some new terminology and then we'll just build from there. Relation is the first word we need to look at, and then we're going to come back and make sure that you feel comfortable with what a function is. So that is the two primary things that we need to do. Of the two learning targets, this is the most important one. This will be important to keeping everything straight for the second learning target, but you'll see how that fits in underneath the first one here in a bit. What is a relation? Quite frankly, it's just a set of ordered pairs. If you remember, an ordered pair is what you actually graph on a coordinate plane. So let's just say we had a point of an ordered pair of 2, 1. How about -1, 3, 4, -5, and how about -6, -7? It's kind of hard to write on this right now. Let me just kind of clean that up. So -6, 7. At the same time, though, you're used to seeing the ordered pairs like that in parentheses separated by a comma. You also know that the very first number is always the x value and the second one is the y value. That means that you can actually take those same values and put them inside of a table. So let's go ahead and do that down here on this table right here. X value is 2, the y value is 1. Then we take a look at this one. X value is -1, y value is 3. X value is 4, y value is -5. I'll use a different color right here. -6 for x and +7 for y. We really don't even need these last two parts of the table. We can do the exact same thing with the vertical table that's underneath those two ovals. We'll get to that in a second. Let's go ahead and put some of these values in. 2, 1, -1, 3, and 4, -5. Those three things are trying to show you the exact same information. They're showing you a relation, and a relation is nothing more than a set of ordered pairs. Okay? It could be 2 pairs. It could be 3 pairs. It could be 500 pairs. We're not really picky with how many. It's just a set of ordered pairs. Now, what do the ovals mean? This is called a mapping diagram. And let's just say that we've got, let's use a different set of ordered pairs. Let's say your x values are 2, 3, 5, and 10. And let's say that your y values are 4, 5, 6, and 6. The way you would read the mapping diagrams, you usually have arrows associated saying, hey, this x value is paired up with this y value. This 3 is paired up with that 5. And you could say, hey, this 5 is paired up to that 5, and sometimes you'll see a split, just like this. It's a mapping diagram. And what's handy about it is it shows you the exact same thing that we were showing on these tables. If I get rid of these tables with the first relation, let's put the second relation into it. Remember, we said this 2 is associated with 4. So 2 was the x, and 4 was the y. This 3 right here is paired up with this 5. So we'll say 3 is x, 5 is y. Then we get to, I'll use a slightly different color here. This 5 is not paired up to the 6. Instead, it's paired up to this 5 because the arrow was drawn over showing it to us. So 5 was the x value and 5 was the y value. And then lastly, we've got this happening here. We've got this 10 is paired up to the 6. And it's still paired up to this 6 too, but since it's the same number, we don't have to repeat it again unless we just feel like it. So we really don't have to do this over again. It's just showing you the same information. You'll see a lot of different variations, but please just understand that All it's trying to show you, whether it be in a table, a mapping diagram, or a set of ordered pairs, is, hey, here's the set. Now they're going to be asking you, is this set a relation? Is it a function? And it just moves on from there. Almost always it's a relation. Let's move on to the next thing. What is a function? Basically, think of it as an input-output machine. We're going to stick a number into this function, and it's got a function rule. Here's the function right here, and this is the rule. It tells us what to do to this number. So if somebody said, I'm going to stick 0 into this machine, the machine analyzes it, and it checks its function rule, and here it says add 7 to the number. So 0 plus 7 gets us the output of 7. If I put in 10 for the number, it checks the rule again, and it says, 10, I have to add 7 to it, so my output is 17. If I put in -3, sorry, I should put that down on the table. -3 plus 7, because this is what the function rule told us to do to the number we put into it. -3 plus 7 is going to be +4. Anything that we put into this function rule is going to do it. So if we said, hey, what about x? Well, that's not a number. Well, it stands for a number, we just don't know what it is. It's still going to be the same idea of x plus 7. So your output is going to be x plus 7 because we don't know what else to call it. So how do we tell if a relation is a function? Let's say that we had this mapping diagram given to us. 2, 3, and 4. And let's just say 6, 8, and 10. The 2 is paired up to the 6, the 3 is paired up to the 8, and the 4 is paired up to the 10. Keep in mind, that means we have ordered pairs of 2, 6, 3, 8, and 4, 10. That's another way of looking at the same set, the same relation. Very simple rule. If your inputs do not repeat, then it's a function. So what's the input on this? All that I see is an x and a y. An x, a y. X, y. We can call x input. So wherever you see the x value, we can call it its input. So this x right here is actually going to be the input, and this is what your output would be. So if you had this machine and it said, follow this rule, if you shoved this 2 inside of this box for this function rule, it'll spit out 6. And if you put in 3, that's its input because it's an x value. It goes through this box and it puts out 8. And if we look at the input of 4, the output, or the y value, is going to be 10. If you don't see the input repeating itself, if it's just the only input is 2, 3, and 4, and none of those numbers repeated itself, yes, it is a function. We just took a look at converting this format right here. So instead I'm going to change the screen here just a little bit, and I'm going to say, hey, is it a function? Are the relations a function? So let's take a look at this one. 4, 1, 4, 2, and 5, 3. Let's take a look at this one. 6, 1, 6, 1, and 10, 100. Let's take a look at this one. 4, 2, and 1, and let's just have 2 and 0 right here. And lastly, let's take a look at this one. 1 and 2, 3 and 4, 1 and 0. Let's change that, I don't like 0. Let's make it 1 and 5. Nope, sorry. Let's change both of them. 5 and 6, 3 and 4, and 7 and 9. So let's look at relation number 1 right here. Is this relation a function? The relation just means set of ordered pairs. So let's take a look at our inputs and find out if it's a function. Let's see, that's a 4, and this is a 4, so they repeated. It doesn't mean that it's not a function. What it means is, if I put 4 into it, I'm going to get an output of 1. If it's a function, it's going to get me 1 every single time. When I put 4 in again, it should get me 1. It did not get me 1, so this is not a function. Let's take a look at the table over here, the vertical table. 2 of the inputs repeated themselves, so let's do the check. Did this input get me the same output both times? The first input of 6 got me 1, and the second time I put 6 in again and it still got me 1. So yes, this is a function. Now we can take a look at this mapping diagram over here. And remember, what it's trying to show us right here is we have an ordered pair of 4, 2, we have an ordered pair of 2, 0, and we have an ordered pair of 1, 0. And I guarantee you somebody in class right now is going, that's not a function because you've got 2 zeros right here. Remember though, that's your outputs, that's your y value. We don't care about that yet. Check your inputs. 4, does 4 show up again? No. Does 2 show up again? No. Does 1 show up again? No. This is a function. So if at this point you're starting to get overwhelmed, I want you to breathe. Remember this. We're asking you, are these relations a function? A relation is just a set of ordered pairs. We can show it to you just like what you're used to in ordered pairs, or we can put them into tables, or the mapping diagrams. That's what's new, and that could be causing you problems. If that's what's causing you problems, that's what we've got to focus on for right now. But if you can keep that straight, remember, relations are just sets of ordered pairs, and then a function is pretty much this. When you put a number in, it's going to get you the same number every single time. And so when we see if that number repeats for the input here, it better get us the same output, and that's going to be a function. Over here, we put in 4 twice, and it didn't get me the same number. It didn't get me the same output each time. It was different. And so that's the reason it's not a function. So let's take a look at this very last one down here. I have a repeating input at the 3. That doesn't instantly mean it's not a function. It just means I need to go check 3's output both times. The output for the first 3 was 4. So if I can get 4 for the next time I put 3 in, it looks like it's going to be a function. There it is. Got me the same output both times? Yes. This is a function. So let's go through and take a look at what these names are. We know an ordered pair is made up of an x and a y. So that first number, the first number, we know it's called an x. The second number, we know it's called y value. We can also now call it input because that's what we put into the function. That's what we put into the function machine, if you will. And what we get after it runs through that function is we call it an output. So we put in the x value and it gets us the y value. We put in the input and it gets us the output. And just to kind of keep you fresh for what's coming, we have the domain, and we call it the range. It sounds kind of funny, but remember, my son's name is Jonathan. I call him Johnny, and sometimes I call him John. So in the same way that Jonathan means the same thing as Johnny, it's the same thing as John, I know that X is also referring to something called an input, and it's also referred to the domain. It's just a different nickname. And then we get over here to y. Another name for y would be the output, and another name would be range. I know this is a lot to take in. Let's go see if we can do better with the work now. Ask questions. Don't sit there and pretend that you know everything. Don't sit there and pretend you don't know anything. Do your best and start asking questions. Good luck.